Hey curious minds, welcome back to the channel where we dig into the wildest, most fascinating corners of science and beyond. Today we're tackling a question that's equal parts thrilling and chilling. How radioactive and dangerous is uranium? You've probably heard of this stuff. It's the heavy metal that powers nuclear reactors, fueled the atomic age, and stars in countless disaster movie plots. But what's the real story? Is uranium the glowing green villain we imagine, or is there more to it than meets the eye? We're about to unravel a tale packed with mind-blowing facts, surprising history, and some seriously cool science. From glowing rocks to secret mines, from atomic bombs to everyday exposure, this journey's got it all. So buckle up, hit that subscribe button if you haven't already, and let's dive into the radioactive world of uranium. Now, before we get into the nitty-gritty, let's set the stage. Uranium's been around since the Earth formed, lurking in rocks, soil, and even a tiny bit in your body right now. It's a naturally occurring element, number 92 on the periodic table, and it's got a reputation that's larger than life. But here's the kicker. Most of what you think you know about uranium might be skewed by Hollywood or half-remembered science lessons, so let's start with the basics. What is uranium? And why does it have such a dangerous vibe? Picture a chunk of uranium ore sitting on a table. It's not glowing green, sorry, comic book fans. It's more like a dull, silvery gray rock with a metallic sheen when refined. Uranium's heavy, denser than lead, and it's everywhere in tiny amounts. The Earth's crust has about 2 to 4 parts per million of uranium, which doesn't sound like much until you realize that's enough to fill massive deposits in places like Australia, Canada, and Kazakhstan. But what makes uranium special isn't its weight or abundance, it's what's happening inside its atoms. Uranium is radioactive, meaning its nucleus is unstable. Over time, it spontaneously breaks apart, spitting out particles and energy in a process called radioactive decay. This isn't something you can see or feel right away. It happens on a timescale of billions of years. The most common form, uranium-238, has a half-life of 4.5 billion years. That's about the age of our planet, so half the uranium that was here when Earth formed is still kicking around today, slowly decaying into other elements like thorium and eventually lead. But here's where it gets interesting. Uranium doesn't just sit there quietly. As it decays, it releases alpha particles, tiny bits of its nucleus, along with some beta particles and gamma rays. Alpha particles are heavy and don't travel far. They can't even penetrate your skin. Beta particles are lighter and sneakier, while gamma rays are pure energy, slicing through matter like an invisible laser. Together, this trio makes uranium radioactive. But is it dangerous? Well, that depends on how you meet it. Hold a chunk of raw uranium ore, and the radiation's too weak to hurt you much. It's mostly alpha, blocked by your skin or even a sheet of paper. But grind it into dust, inhale it, or eat it, that's a whole different story. Those alpha particles can wreak havoc inside your lungs or stomach, damaging cells and raising the risk of cancer over time. So, raw uranium isn't an instant death sentence. It's not like you'll drop dead from touching it. Miners have handled it for decades with basic precautions, but its danger ramps up when you concentrate it, refine it, or turn it into something weaponized. And that's where history comes in, because humans didn't leave uranium alone in the ground. Oh no, we dug it up, cracked its secrets, and changed the world forever. Okay, so uranium's got some radioactive quirks, but it's not exactly glowing with menace yet. Let's shift gears from its natural state to the moment humanity realized this heavy metal could do a lot more than sit in rocks. Buckle up, we're heading back to the dawn of the nuclear age. Let's rewind to the late 19th century. In 1896, a French physicist named Henri Becquerel was messing around with uranium salts, trying to figure out if they could emit rays like X-rays, which were all the rage back then. He left some uranium next to a photographic plate wrapped in black paper, and when he developed it, bam, there was an image. The uranium had fogged the plate all on its own, no light needed. That was the first clue it was spitting out something invisible and powerful. Becquerel had stumbled onto radioactivity, and uranium was the star of the show. Fast forward to the 1930s, and scientists like Marie Curie and Enrico Fermi were digging deeper. Curie's work with uranium ore, specifically pitchblende, helped her isolate radium and polonium, earning her 2 Nobel Prizes. But it was Fermi and others who cracked uranium's real superpower: fission. In 1938, German chemists Otto Hahn and Fritz Strassmann bombarded uranium with neutrons and found it split into lighter elements, releasing a ridiculous amount of energy. This wasn't just decay. This was an atom shattering, unleashing power millions of times greater than any chemical reaction. Why is that a big deal? Because when uranium-235A, a rare isotope making up less than 1% of natural uranium, splits, It kicks off a chain reaction. One atom splits, releases neutrons. Those hit other atoms and boom, you've got an exponential explosion of energy. By 1942, Fermi built the first nuclear reactor in Chicago, proving uranium could sustain this reaction. 3 years later, in 1945, the world saw what that meant. The atomic bomb. Little boy dropped on Hiroshima used enriched uranium to unleash devastation unlike anything before. Over 100,000 lives lost in an instant, all from a grapefruit-sized core of U-235. Suddenly, uranium wasn't just a rock, it was a weapon, a power source, a game changer. But here's the crazy part. Even in that bomb, most of the uranium didn't fission. Only about 1% of the mass actually reacted. The rest just scattered as radioactive fallout. That's how potent this stuff is. A tiny fraction can level a city. So yeah, uranium's dangerous when you weaponize it, but it's also a testament to human ingenuity and our capacity for destruction. All right, we've seen uranium go from a quiet mineral to the heart of the atomic age, but let's bring it back to Earth, literally. How does this radioactive rebel show up in our daily lives, and should we be worried? Spoiler, it's closer than you think. Believe it or not, you're exposed to uranium every day. It's in the soil under your feet, the water you drink, even the air you breathe. Just in trace amounts, the average person ingests about 1 to 2 micrograms of uranium daily through food and water, mostly from plants that suck it up from the ground. Your body's got about 90 micrograms of uranium in it right now, mostly in your bones. That's a millionth of a gram, so tiny it's harmless. Your kidneys flush it out before it can do much. But uranium's not evenly spread. In places like the Grand Canyon or parts of India, natural deposits spike radiation levels higher than average. In the 1950s and 60s, uranium mining boomed in the U.S., and miners in places like Utah worked with raw ore daily. They weren't dropping dead on the spot, but over decades, lung cancer rates spiked from inhaling uranium dust. The radiation wasn't instant poison, it was a slow burn, damaging DNA over time. And here's a wild fact. Uranium's in old stuff you might have seen at a flea market. Before the 1940s, it was used to color glass and ceramics. Think bright orange Feist-aware dishes or yellow-green depression glass. Those items emit low-level radiation, detectable with a Geiger counter, but they're safe to display. Just don't eat off them every day. The risk is tiny, but it adds up. So uranium's not lurking to zap you, but it's a reminder of how nature and human tinkering intertwine.